Welcome back for another video in our ongoing series of educational content that we're putting out. And I am so glad to have a prior guest that we've had on, Tom Wire, who is a NETA 4 NISET 3. He had a long tenured career in working as a field service technician and has recently become a senior training technician at RISA Power. Tom, welcome back, my friend. How has things been for you?
Doing good, man. I'm glad to be back. Glad to make some more content with you. Yeah, I did have a transition over to Reset Power and liking it, really liking it so far. So hopefully we can make good things out of it as a training specialist with them.
I think it's a great role for you, man. And like I said, the work-life balance part is definitely a much better place for you, as we've discussed. So congratulations once again. And for the audience today, what we're going to do is, so Tom and I have been brainstorming in the background in what could we do to offer some true educational content to you guys. And so he and I came together, and we today are going to work through what we're coining as Multimeter 101. And with that being said, Tom, you want to kind of give us a framework for what we're going to be discussing today? And a lot of this is going to be a refresher for me. I haven't delved into being a tester of any kind in quite some time. So I'll turn over the floor to you to kind of cover what we're going to be covering as far as content today. And then, of course, I will chime in with any random questions that I think the layman may have, like myself, if that works
Sure.
for you.
Yeah. So I like to go over is how does multimeter work? Where did these things come from? And then we can go back and forth as far as what kind of meters are out in the field and technicians, like what should they put in their kits, depending on what kinds of situations they run into. I'll start it off with the first thing would be what is this little multimeter? What is it? This little magical box. Like I have a slew of them over here. I mean, we'll go through them probably one by one, honestly. But how does this little magic box work when you turn this thing on? What the heck is it doing, right? And so it's not as complicated as a lot of people think. It's just engineers would say this is basic AC and DC electrical theory. And so this right here is an analog multimeter, and this is where it all came from, right? Analog just means I don't have ones and zeros in digital. I get 2 amps and my needle goes this far. I get 5 amps and it goes further, right? It's analog. It's like the hydraulic stick on your tractor. You push it further, it goes farther. So where did it all come from? Well, let's talk about the voltmeter first, right? The voltmeter is probably one of the easiest ones to wrap your head around. And so when you look at the basic circuit for a voltmeter, what you're going to see is you're going to see that you want to measure a voltage, right? And so the voltage is going to be the load. It's going to be whether it's the main terminals of a 480 volt panel, or you're going up to a motor while it's running, and you just want to measure, how much, what the voltage of the load, the motor, what is it receiving? And so in order to do that, what we have right here is a voltmeter. Now, this little back right here, doesn't really matter. I'm gonna pop this little cover off, but and you can see this is a real one. It moves and everything. So this little paper, we can change this out. If we change the components in here and whatnot, we might affect the scale of the meter. It might go from 0 to 100 right now, or it might go to 0 to 5,000, depending on what how we design the circuit. But this is just a piece of paper, we could change it. So how does this thing work? It's all this is, and I don't know if I'm going to be able to get it really good, but because my camera focus. But all this is it's just a coil of wire wrapped around a little armature, and that armature can spin freely, and it's a very soft spring in there that keeps this needle going back towards the zero position, right? And then that little armature, it's just free floating like this. We put a magnet here and a magnet here, and if we go ahead and apply a magnetic field, or a current, the magnetic field wants to chase the one that we have around it, and so the needle moves, right?
Now,
So
I
now
want to
all
kind
I
of
have
chime
to
in
do,
too to kind of
go
take
ahead.
it back to super layman's terms right quick. Why would we want to measure voltage for anything in general? What's the point, I guess?
Lots of good reasons, right? Um, your walls in your house, you can only put 110, 120 volts to your TV. So if what happens if the transformer on the pole's going bad, you know, you might want to verify that. There's a lot of new installations when you're building substations that you need to measure the output voltage before you put something into service. There's a lot of good reasons. Troubleshooting if you're having issues with a motor. There's a lot of good reasons to measure voltage.
Gotcha. Just want to make sure
So
that everybody's kind of tracking as to the why. So we have current, we have voltage, we have resistance, and kind of
sure,
how all that stuff kind of ties in. That for those who aren't necessarily familiar with electrical theory.
absolutely. So well, this little coil though, the only problem with this is that it's just a coil of wire and it's practically a dead short because it's just a piece of wire. So in order to make this controllable, what we do is we put a resistor in series with it. And then we can, if we make that resistor adjustable, then now we can calibrate this meter to our scale. So we can adjust it up and down. And then this meter, when we say it's at 400, it's actually on 400. So we would apply 400 to the circuit and make sure that the needle stays on 400 and then move it, or reprint our scales so that way it matches our meter, however you have to do it. But that's the basic concept of a voltmeter. And then, as the digital world came out and advancements, we just took what we already had and made it digital. So that now we have the magic boxes.
Right. Now, do you find that as far as accuracy goes, because accuracy is huge when we're testing any kind of stuff, especially when you're doing acceptance testing and things, do you find that analog is better than digital, digital better than analog, or are they pretty comparable?
So there are, I would say they're very comparable. The digital ones typically aren't calibratable. The analog ones typically are, and they some because they're mechanical devices, they typically should be calibrated. A lot more frequently than you could probably get away for 10 years of not calibrating a digital multimeter, right, and just not tell anyone. But the analog ones, you might want to look into it and make sure once a year.
Gotcha.
There are some advantages of a digital multimeter versus which I'm going to demonstrate here in a little bit. But like a digital, it goes a lot. It's like look at the speed limit in most people's cars on their dashboard nowadays, right? It just puts up a number for you. It's so much more convenient.
Right.
But there are advantages of having an analog one, and I'm going to show one of those later, which is really really handy. Um, so if you want, we can go into the ammeter now.
Yeah.
And then, so on an ammeter, the problem with an ammeter, and if you look at the basic circuit for an ammeter, is you're going to have a meter like this, exactly the same thing. But the problem is an amp. If you want to measure amps, you have to measure it in series. So you have to put this in the circuit. But if your load is 100 amps, you're going to blow your meter,
Hmm.
right? So you don't want to do that. So in order to do that, what we do is we install what's called a shunt in parallel with it. And so this little shunt, I have four of them here. The big ones, small ones, and if you look at old GE equipment or something like that, you might see these in there because they have a panel ammeter on the front, and then they have one of these. And so 500 amps would run through this. But if you put your little secondary connections, here they are here on right here, you run this to your meter, it only pulls off 1 to 100 milliamps, and that's what runs the meter. And then your 500 amps goes through here. So this is a known built resistance, and we basically shunted the majority of the current through, but a small part goes in a parallel path. And
Gotcha.
we run the meter the exact same way. So you just redo the scale, calibrate it as needed.
Makes sense to me. Now, can you kind of touch on some of the construction of the shunts? I noticed they have some are air gapped in between the runs, some are solid all the way through, and kind of can you talk to that to some extent?
Yeah. So I'm gonna start off with the let me find the smallest one here because let's start the small. So I'm a really big nerd, and I
You
went
and me
on
both.
each of mine, and so this is the smallest one. This is a 10 amp shunt, and all of them you might say that they're air gapped. They kind of appear that way, but they're not. They're solid all the way through. It's a solid conductor all the way through. It's just the thing is we built this in such a way that we know what the resistance is from this point to this point, and they're designed and they're specified in such a way that this would say 10 amps, 75 millivolts. So if I run 10 amps through this from here to here, it will be 75 millivolts of a voltage drop from here to here. And so now you can design your meters that way. And then I went
Now,
through
is
and I
there a
wrote it right
difference
in
in
the
the
notes.
various materials used to kind of achieve those resistance levels?
Yeah, so it depends on what they want to use. Engineers have resistances based off of cross-sectional area charts based off of material. So copper versus aluminum versus silver, and these are all painted so that way corrosion never becomes a factor on the shunt. But like this one is just a solid bar all the way through. It's not squirrely like this one right here, but this is a 50 amp shunt. And then this big boy right here, it's all solid bars. It's actually five of these solid
Mhm.
bars. So that way you know for sure exactly what the known resistance is. And then before they finally secure these and solder them together, there's actually channels in here, and they can just slide this open or close, and then they can build. I don't know if you can see it really. There's a notch right here, and they can actually. I don't know if I can get there. You
I
go.
see it. There you go.
Yeah, on each one of those, there's a notch, and you can actually just get out there. So if this is off by just a hair, you can get out there with a hacksaw, no joke, and you can just make it a little bit deeper, right? And so that way, if you make it a little bit deeper, you increase the resistance of this, and therefore your voltage drop goes up, and now you just made the shunt exactly to specification.
Now I'm going to have to ask the goofy question: why does the hacksaw work in increasing the resistance?
So the way it's working is you're actually changing the cross sectional area, right? So you're taking away conductor material, and so because you take away the conductor, it's like comparing a 14 gauge wire to a 22 gauge wire. So the resistance goes up. That's what happens.
Gotcha. I like it.
So
So we've got
those are
shunts,
my
and
shunts.
now
Pretty
we
cool.
know that because you wouldn't want to blow out the meters. Obviously, that's a concern. Anytime you over voltage, there are sensitivities within a meter, and that would be on the digital side or the analog side. You can obviously pop a fluke just like you can an analog if
Absolutely.
you're testing the wrong things. So totally makes sense there, and why you would use shunts. Are there any other use cases for shunts outside of the ammeter side of things?
There sure are actually most calibration entities, whether depending on what they're what they do. If you have a primary injection test set that it's used for testing breakers, or a secondary injection test set, and you want to calibrate it, shunts are one of the biggest things in the field known, because the thing is they never change, right? All this paint on here, yeah, it might
Doesn't
make it
matter.
harder for heat to get out, but it prevents corrosion, and that way the known resistance should never really change. This thing should
Right.
should be a known, like, what is it? I labeled it on here. It's a This one is 500 volts, or sorry, 500 amps at 75 millivolts. And I did the math. It's 150 micro ohms. So if you have a primary injection test set, you put it on there, you say, give me 500 amps. You should meter,
500.
75 millivolts from here to here.
Right.
If you have a DLRO, digital low resistance ohm meter, completely different test set, right? Now we're measuring, we're going from injecting current to measuring a very, very low resistance.
Right.
This is a very, very low resistance that should never change, right? So you can essentially do the exact same thing, but you have to realize that it's 75 millivolts from this point to this point. So your DLRO should only be hooked up from this point to this point. If you go from this point to this point, you're adding more material, which becomes a longer conductor, and your resistance will go up.
Makes sense. I like it.
So yeah, plenty of good uses for these things. And then I like to use them when I'm building certain types of equipment, whatnot, to make meters and stuff. So there's a lot of good uses for them.
Definitely, definitely. And a great explanation of kind of the difference between the voltmeter and the ammeter, and the series and parallel aspects to both. So good
Yeah.
stuff.
So if you look at the third diagram that we have, um, you know, you have a known resistance. That's what's going to determine, it's your load, right? It's your motor, right? So you have a 480 volt motor, and your resistance is a pump or whatever it is, right? And so you want to measure the voltage of that motor. Well, you're going to do it in parallel, you know, with the pump and the source, right? But the ammeter has to see all it's like water through a pipe, right? It has to see all the current going through it. So you have to push the current through the ammeter.
Makes sense. Makes sense. I think that's a pretty thorough layman's explanation. It kind of makes it easy enough for most of us to understand. So,
Yeah.
like I said, I've been away from the testing side of things, so that definitely was a good refresher.
Well, it's good because I'll be honest. When I was younger and I was still learning, I was trying to do something on my car, and I was like, well, hold on a second, what kind of light? But I want to change. I was trying to make cool LEDs in my car, right? And I was sitting there, I was like, well, I don't want to burn
I
out these
think we all
LEDs. I'm
did.
trying to be smart in my stupidity, and well, what did I do? I was like, what's the current that's going to pass through this? And I didn't know that the LED did operate the way it did. So what did I do in my my puny little mind? I took the current leads and I put them directly across positive and negative. And what did I do? I put
Blew-
I basically took the current leads across the battery and I shorted the battery through my meter and I popped the fuse.
Yep.
And I was like, well, my current's zero, because it popped so fast I never got to see
You
current.
never saw it,
Right.
right?
And so, I'm sitting there, I didn't know any better, but that happens so many times out in the field. I mean, if you go up to technicians, you say, "Hey, let me see your multimeter," and you make a basic little circuit with a resistor and a battery, and you just hook up the test leads just to see if you can pulse current through their meter and see if it works. I'm telling you, like half the technicians I run into, their fuse is blown in their multimeter because they just
Really?
don't know how to
That
use
it's
it.
it's that prevalent?
It's a very common thing in the field. Yeah, it really is.
Now, and so you said that's one of the. I guess that's probably the easiest way to take a normal 12-volt battery or something like that, check it, and that's a good test for the fuse. Is that pretty much the de
Yeah,
facto?
you just have to. Here, let me get one of these meters right here. So I have a couple different meters here, and one of them, dang, it's going to be really hard to see this. Well, actually, this one's not bad. So when you look at this meter, some meters nowadays, like the insulation resistance, the Fluke 1577s, they only go up to 400 milliamps, and I don't know if you can
You
actually
can see
see
it.
that.
Yeah,
But
it shows.
this is an older meter. This is a Fluke 179, and this one right here is a Fluke 77, and this one's really beat up. I kind of like this one out in the field, but these have 10 amp inputs also. So you have a 400 milliamp and a 10 amp input. You have to make sure that you're on the right
Hmm.
selection, right? Because this is only going to look at this input. So if you're injecting on this input, it'll never
It's
see
not
it,
going to do
right?
any good, right?
But there's also two different fuses here. So when you take this thing apart and you look in the backside or back here, you have to open up this little door. There's two different fuses. There's a big fuse and a small fuse.
So, and it sounds like basically, if you're out in the field and you may not know that fuse is blown, and you can still be out there testing, or what are they going to see as indications that would drive them to want to check the to make sure the fuse is good if it's
Or
prevalent?
they just have to check themselves. They have to take it's not terrible to do it. So the resistance mode still works on these multimeters without that, right? Because the resistance goes across this. If you
Hmm.
look at these little inputs right here, it tells you, voltage
Right.
or ohms or diode method, whichever one you select up here. All of these are off of these two inputs. These two inputs are only for your amperage inputs.
Hmm.
So, I mean, the meters are labeled to tell you how to use them, but all you have to do is just, take the back off right here, open these two screws. There's two fuses in there. They're a pain in the butt to find those fuses, but they're on Amazon. It's just if you go
Right.
to a regular Walmart, you're probably not going to find them.
Gotcha.
And then you just select it to resistance and, use your leads and test the fuse. That's all
Hmm.
you have to do. So a lot of people like to use the beep mode. Beep mode is good too. But those little 400 milliamp fuses, this can have higher resistances sometimes, and beep doesn't always work. But the 10 amps always work good. So I just stick with the resistance mode. But it should be less than 1 ohm on both.
Gotcha. I like it. I like
So,
it. I
but it's
like it.
very common for people. And the thing is that they'll blow the fuse by accident, whatever it is. But then they just get so busy out in the field that they never bother to check it. And how often do we actually have to measure current? Seldom,
Not, yeah,
So
exactly.
by the time that they need it again, might be 5 years, and so they've
Right.
never checked it in 5 years. And be like, yeah, my meter is blown. That's what I'm saying. It could just be so prevalent. And half the people with their meters have blown fuses don't know it, or they knew it at one time and or someone else blew it by accident, and it's just never been replaced since.
Now, when you were in the field, did you make it a habit to check your did you always check it before you went out in the field just to make sure that the fuse was good?
Yeah, I mean, if you've seen my LinkedIn content, you know that I like to do functions checks. So absolutely, yeah. There are some ways that you can check this with another meter. Pretty cool. But there's actually a couple cool tricks that you can do with a multimeter that a lot of people don't know. But you can take another meter and just run it through, right, and test ohms. And this is going to put out a voltage, but it can only go so high before the meter's not going to smoke itself.
Right.
So it only puts out so much current, but then you can measure the the shorted current of that through the other meter, and you can actually see if your stuff's working. But it won't be anything really measurable.
Gotcha. Gotcha.
It's more of a functions check.
I like it. So on multimeters, what else should we know about multimeters from a layman's perspective here?
So there's a lot of cool things. I got a lot of meters over here, right? So this is a very typical standard meter that you'll see a lot of places. This one and this one, just a basic fluke meter. And like I said, pay attention to all the stuff. This is one thing that gets a lot of people is you've got on here white symbols and yellow. Well, yellow only applies when you press the shift function, right? So it's like on your computer, you got to press the
Right.
function button or whatever, or on your calculator, and then that puts you in the other mode. So if I'm right here on tone, which is beep, right? Continuity check,
Mm-hmm.
great, right? But it won't be in diode check until
Till
I
you hit
push
the
the button.
button. Yep.
So there's a lot of those on there. A lot of people don't know it. Some meters also have blue options there. So they have another button there, but it just depends on functionality. I'm pretty sure what I'm talking about is the 1577s. They have a blue button where you can also push it to change your range or something like that.
And that's the big thing as they get more complex, or at least that's been in my humble experience. Is like so. You only have so much real estate on the face of the meter, and so you offer a shift mode, and then they can offer a third dynamic that'll
Yep,
allow three modes of functionality, basically.
yep. This is a FLIR multimeter. I love this little
Ooh, that
guy.
one's sweet.
Um, and it's a pretty sweet little meter. This is actually one of their IR camera ones, so I can
That's
actually
cool.
do IR inspection at the same time. But it's not real high quality inspection, but it's good enough to get you by a pickle if you're in it. But there's a lot of cool functions on here, like low Z and stuff like this. This is really good for a lot of people don't know what low Z is. It's a low Z. Z stands for impedance.
Yep.
So it's low impedance input. So most of your multimeters are a high impedance input, like I was talking about with the voltmeter, right? You don't want to measure something with such a low resistance that you drop the voltage of the circuit, right? You want to use a high resistance input so that way you don't affect what you're measuring.
The
It's
load, right?
one of the rules of metering, right? And so, but the problem is when you're in like low voltage wiring, you might have a ghost voltage going on in your walls. And you're like, I can't find this thing.
Mm-hmm.
I don't know what the source is. It's it's usually induced voltages from another line. And so this low Z is really cool because this is a low impedance input now. So they lower the impedance, and therefore all your ghost voltages, which were actually not real, um, they're shorted out through the meter. And
Makes
now you
sense.
don't ever see them anymore. So you're like, no, I put it on low Z. I'm not seeing anything.
Can you
So
kind of
you don't
touch
want
on
to
that
run.
too? So, and we talk low impedance and ghost voltage. Can you kind of explain how ghost voltage can be introduced into residential wiring? Because I think that's a unique
Yeah.
concept that people may not understand. You know what I mean?
Yeah, no. So if you have, say, you have two parallel wires, right? You got one circuit that runs to the garage and one circuit that runs to the bathroom or whatever, right? Well, if you turn on one, and if for a while, and say throughout the kitchen wall, they run parallel with each other, right? So now if I turn on the switch on one, right, I'm going to flash a voltage across that circuit. That circuit now became live. Well, the other circuit is, since it's in such close proximity, it acts like a capacitor, and it
Mm-hmm.
sees some of that flash, right? And
Yep.
so if you take a multimeter over to it, you're like, "Whoa, what's going on here? I never turned this circuit on." But it's just it's a lot of people call it a ghost voltage is what they call it.
Right.
And that's all it is. It's just an induced voltage. That's the engineering concept of it.
Right.
The layman's term is a ghost voltage,
Right.
but the
And
low Z
it's
is the
mainly
way
due
to
to the
kind
fields
of
it's really a lot of people don't realize that there are invisible fields that come off of a power source, and that's kind of how you get the transient voltages or ghost voltages or whatever you may see.
Yeah, all it is it's magnetic induction from one
Yep.
circuit to the other one. It's exactly how a transformer operates from the primary to the secondary.
Yep. And can be wired
So
for step up, for step down in a transformer.
yeah, but I mean, the proximity of the circuit makes a big difference of it.
Yep.
Romex, it usually carries the ground wire, but if you have two circuit, that's a big one. Is when you see two, just a hot and a not, hot and
Mhm.
neutral running for a little while, and then they don't have the ground or something nearby, it can affect it too. But so the low Z is really good for that. There's other things on these meters where I'll go into one that you don't really see people use very often. It's this little on this one it's yellow, but it's a thermocouple. It looks like a little thermometer, right? And it's a plug that you plug in right here, and it's a thermocouple on the other side. Really cool. I can show you a trick later if we have time for it, and you'll
Can
see
you
it on
tell
other
everybody
ones
what a
too.
thermocoupler would be used for?
Yeah, let me pull one out first.
I figure you had one laying around over there somewhere.
Pull it lying around here. Actually, let me grab the good one. So this is the one that typically comes with the fluke. Okay,
Mhm.
a lot of people are like, "Yeah, you'll never need that. Throw it away." That's what they tell their new guys or something like that. But what it is, and since we're on the subject, I'll show you the cool trick. So inside of a meter, and I have to use this one because this fluke meter has the thermocouple option on it. Okay, so inside of this meter, you have a circuit that is used, and all a thermocouple is basically two types of metal at one junction, and they're dissimilar metals, right? They use these in exhaust circuits and stuff like that, or on engines to measure temperature. And so because they're dissimilar metals, you have a hot junction and a cold junction, right? And so because they're dissimilar and you have a temperature difference between the two metals, they'll build a voltage. And all we care about is measuring the voltage. We're not going to let the current flow. We just want to measure the voltage. And
Right.
so if you put this, I switched it over to, I turn the light on, maybe make that a little easier.
It helped a little bit.
I
Yeah.
switched it over to that mode, but the problem is I'm still on the white option because I didn't press the yellow button.
Right.
So now I'm on, and it says C in the top right.
Mm-hmm.
So I'm going to plug this guy in right here. And it says that my thermocouple's temperature in Celsius is 23, 22.9. But watch this. I put my fingers on there. Well, you know what I did? Plugged it in backwards.
Just goes to show you.
So you have
Yeah,
to
I
make sure
mean,
your
you got to
plug
have them
right,
set
so
up
my
right. It all
temperature's
comes
going
down to
up.
user.
Hey, it's a functions check, right?
It is
So
100%.
this is a very good function check. You go ahead and be like, "Wow, I put my finger on there, and apparently I'm colder than the air." Well, no, you just plugged it in backwards because
Right.
you build a DC voltage on this, so
Exactly.
there's polarity sensitive. So if you plug it in backwards, it will
Right.
tell you. And actually, if you look at the thing, it has a plus, yellow plus on there. It tells
Mm-hmm.
you. So yeah, that's all this is. And so since we're on the topic right there, I'm going to show you what's a cool little trick. That in order for this thing to work, you have to have a hot junction and a cold junction, right? This thing is actually able to measure. You can measure temperature with this thing without this. And so, what's the temperature of my meter? Short these.
I'll be dang.
That's the
Okay.
internal temperature of your meter.
Provided you have it set up on thermocoupler mode, right?
Yeah, yeah. So,
That's
like, if you're
wild.
out in the field, right,
Mm-hmm.
and you just have a multimeter lying around, it's been sitting on the desk all day, right? It hasn't been sitting in the sun or anything weird like that, right? Sitting on the desk, you're like, what temperature is that in here? Just short your multimeter and put it on thermocouple mode, and that'll tell you what the internal temperature of the multimeter is. And then this probe will tell you what the external temperature of the probe is.
Gotcha. Now,
Pretty
is
cool little
so
trick.
yeah, it's
This is a
very
really
cool, but I guess like what is there any value add like in doing function checks to shorten it out and getting the internal temperature of the multimeter? And does it establish like a baseline for measurements or anything like that? Or you just try to make sure that the
baseline.
meter's up and running?
It'd be good, like for example, not if you use thermocouples or you use that device and say for example you're out there testing or whatnot and you run into a situation, I don't know, man, I've been getting weird numbers all day or something like that, right?
Right.
Short it, take a look. What if you short them together and it says 99C on there? You're like, dude, I'm
Then you have a
holding
big
it.
issue.
Okay, it's not
Right.
burning up in my hand, right?
Right.
So it's a functions check. Treat it like a functions check.
I like it. I like it. Well, what else should we know about multimeters, Tom? We're cruising along here. So we've talked ammeter, we talked voltmeter, we've
So
talked impedance.
let's go about some other types of multimeters and stuff like that. So this right here is actually a 5 kV measure. But don't be confused, right? Because you can actually put this right here. There's a selection for 750 volts
Mm-hmm.
AC. I can put that on there and I can measure up to 750 volts AC with this thing. So, but just be aware you've got different leads. So the two right here, let me make sure I'm right on that. No, these outside two are your mega leads, but these inside two are your multimeter leads. So just make sure that you're hooking it up right. You have to connect your equipment right. That's the 101. So I went over the FLIR. I love this guy. And then there's another FLIR that I have. This is one that you might see out in the field is common. This is my new favorite meter. But this guy right here, it has open jaw clamp, and then this one right here is closed jaw clamp.
Gotcha.
So a couple things to know about your clamps, right? So this has to open, but you see on the inside it's a magnetic bar. If you don't close that bar, it won't work right. You
Gotcha.
might get a reading, it's wrong. Okay, that
So you
that
have to
bar
make sure
has to
your
be.
gauge is the correct gauge, or you can mess it, or you won't get what you need
Yeah,
out of it.
yeah. You clip on wire too big. Now this little meter right here actually goes down to very small scale ammeter. And so this, I bought this one specifically for measuring clamp on milliamp checks,
Yeah.
um, AC or DC.
All
And
right.
this thing is it's scary accurate
Is
in
it?
milliamp
Didn't you do a
range.
video on that particular one as far as amp clamps
I
go? I
did,
think you
yeah, yeah,
did.
with
Yeah, I remember
batteries.
it.
Yeah, batteries and ripple current. Yeah, that's all I
Yes.
was using it for, and it's scary accurate. But I love this little guy. This one right here is really good because you have to be careful. Because this is open jaw. You can fit whatever you want on there, but this one, like I said, you have to
Have
get
to
the
make
clamp
sure
closed.
the
What's
right.
nice about this one versus a lot of other clamps that you might see, other than the open jaw concept, is that this one actually measures AC or DC current. So there's different types of CTs that they use for these, and Rogowski coils or just normal straight coils, depending on what they're using, or Hall effect sensors. Depending on what they're using, is hardware inside of these determines on whether or not you can measure AC or DC. So
Gotcha.
I've seen it before. People go ahead and they take their clamp on meter. They're like, oh, I'm going to see how much current's going on this battery circuit, and they go out there and they take their normal fluke. It's a yellow fluke box. And they take it, amp and plan, put it on there, and they go ahead and they say, oh, I got 0 amps. Well, yeah,
Your AC.
dummy, because you can't measure DC amps with that thing. And usually it tells you at the top AC. If it has AC and then it's a dash 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 dash, that means it's also DC.
Gotcha.
And so they'll go ahead and be like, there's zero current running through this thing. They think it's safe. And all
Yeah,
they did
no,
was
it's
set
not.
themselves up for failure because they don't know their equipment. They don't know how to
Right,
use it. I've
right.
seen it. So like this right here, that symbol that I was talking about, A with a dash 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 and a squirrely line going with
DC.
it. That means it's AC and DC. But this little guy right here, I like this thing because it's got it's got a flashlight on it. So when you're inside of a panel, it's got the probe leads on it and everything. So I love this little guy.
Very unique piece of kit. And speaking of kit, so let's say you're getting ready to head out on location and you don't know what you're walking into yet. You kind of have an idea. What would you build out as your kit as far as it pertains to multimeters and meters and things like that?
So let's talk about what they basically come with, right? You go ahead and you buy one of these flukes. What are you going to get in the package? Typically, what they'll send you,
A couple of
and I'm going to stick with a
alligators
fluke
and
right now
some
because most
regular
people don't
leads.
want to go out and buy a FLIR. They're not vetted as much yet, but I love the thing. But so let's go with the industry yellow
Yep.
standard, right? The flukes. So you're typically going to get the fluke. You're not going to have it with this magnetic strap on the back, so I recommend it. Why? Because you can go up to a panel, put it up there, you got your leads in your other hand. You can't hold the damn meter, so you can sit there. You could go measure while your buddy's watching that, or you're looking up and you're measuring something. Whatever you
Right.
got to do. So that when you buy this little strap, it's like $15 on Amazon or something like that. I recommend getting the one with the hook attachment
That way you can hang it
because
off
then
various
sometimes,
things and cables if you don't
well, I
have the
mean, what if you're
magnetics.
on a different type of panel, or you
Right.
don't have as much steel or whatnot, and it doesn't, or the magnet's not as strong on this panel because it's thinner, so the hook's really nice that you can grab onto something. And I mean, you can always hook it onto the strap itself right here or something, and use like the chain
Yep.
effect or whatever. But so I recommend getting one of these. The kits when you buy them typically always come with a bag. If they have the thermocouple option, they'll come with a thermocouple. And then if you buy them, they'll typically come with a set of test leads. And these are standard fluke test leads right here. They're not bad. I like them. But when I was, when I was younger and not needing a multimeter as heavily as I am right now, just the standard leads are just fine, right? But as I became more invested in my career, I started finding that, well, what about like, retractable leads?
Right.
Where the sleeve. Now I don't have to worry about accidentally leaning in on a terminal block and I touch another pin,
Right.
right? Or whatnot. I can actually use that and just touch, and there's really only like 2 millimeters there of
Yep.
steel poking out. So you just have to be careful with these because these now have a 4 millimeter banana jack on the back end of them. These are the ones I recommend, and there's a reason. I'll say it in a second. But you can get them where they're like this, and they're just cords coming off. They go straight in your meter. I don't recommend those. I recommend getting something like this because of the other accessories. I always like to keep in my kit just options for you if you're going to build your own kit. Alligator clips,
Yep.
and these
Huge.
are also 4 millimeter. These are the Fluke ones, and these are, I'm sorry, the best ones I've ever seen. I think there's other brands out there, but like these Fluke ones, man, they feel good, they work good, they're nice and shielded. They always bite. They hurt on your finger, like I just did, but they work so well, man. I recommend these. When it comes to the meters, I like the new FLIRs, just personal preference, opinion, and how I use them. But when it comes to leads, man, Fluke's got it in the bag. And so these are all Fluke right here. And then
Now, what's the
we'll talk
price
about,
on like so the ones with the adjustable depth that you just showed? Can you kind of talk price on some of this stuff so techs can kind of know what they're getting into? They're
in
probably
all
fairly
honesty,
reasonable. I'd say 30, $40 probably.
no, these clips, I think that these clips aren't cheap. I think it's like $50 for two of them or
Okay.
something like that. They're not cheap. None of this Fluke stuff is real cheap.
Right.
To be honest, like if you want the basic leads, they're not terrible. I think they're like 15, $20 or something like that. You can get, I got all these on Amazon, so you can get them on Amazon fairly easy and have someone deliver it straight to your door. But
Right.
as far as price, yeah, Fluke does. Look, if you're going to use it and stay heavily invested in it, then it's worth the
Well worth
price.
the
I'll say that.
investment.
But they're definitely not on the cheaper end for something that can be easily broken. So don't let your buddy who tears stuff up handle your stuff all
Right. We
the
all
time.
have that buddy.
When it comes to the small alligator clips, these are good for like when you're inside of like little circuits, right?
Hmm.
And you have like a little stinger wire or something coming off. You just want to clip onto that one little point, but you can't use this or something like that, right? So there's two different types, and I'm going to go over this specifically. I have two different sets right here, and the reason is because I ended up changing over to one. So this first one that I was talking about is the one I want to talk about first. This other one right here is exactly the same thing. I took it out of the sleeve, right? It looks just like this. Clip, all good, right? I took it out of the sleeve. This is what it looks like out of the sleeve. The thing about this one is that there's two different types. You have to be careful what you buy. This one plugs directly into your probe tip, okay?
Gotcha.
Now, when you have the retractables, it works on your probe clip, and nope, this one doesn't screw. So you can get some of them that screw on and stay.
Right. That
So
way it
now
doesn't
you have
back
a
out on
probe
you.
with that's great. Me personally, I don't like it so much because now I have a fixed hard length that I have to also find and accommodate room for,
Right.
right? So these other ones that I have right here actually have a 4 millimeter banana jack on the back of them. They're exactly the same. All the rest of the hardware is the same. It's a very good little clip. And so here's the two reds from side to side, so you can kind of see they're pretty much. This one's
Same
just
thing.
honestly it's just poking out a little bit. They're exactly the same. There's really no differences between them. Just one goes on a 4 millimeter banana jack and the other one doesn't. And by 4 millimeter banana jack, I mean you can go out and get also Fluke has ultra flexible silicone 4 millimeter banana leads, and it's a banana on each side.
Yep.
So these little things just plug right onto it, you know. And hell, you can even I've done this before where I go ahead and I clip on one circuit. I just need to poke and short it because I'm testing a functions check.
Right.
I don't even need the meter, but now I have jumpers. I have,
Hmm.
I have shorting leads or whatnot. So that's why I really like this setup versus the stuff I was using prior. But lots of good options. Fluke, I'm telling you, I feel like they have it in the bag when it comes to test leads, but I'm
And this
starting to
may
like
be
the
kind of
FLIR a little bit more.
a layman's question for you here. So you can use the Fluke leads on the FLIR units as well, correct? They
Yeah.
work pretty well,
So
no issues or anything like that.
yeah, the four. This is a industry standard 4 millimeter banana jack.
Yep.
So it'll fit in any 4 mm banana jack. And I'm
And
just going
that's
to
what the
grab this
FLIR
one.
runs is the 4 mm banana jacks.
Yeah, they all these meters do. So
Okay.
it works on this one. It works on this one. It works on it just. I know someone's going to be
Everything.
like, nah, I don't believe it, So I'm going to show you
Right.
right
You got to
now.
go ahead and do the actual
Works,
functional check.
like why not live right here in front of
Well,
you?
I mean, it
Does
makes
that
sense,
work
right? And
on
that's
these?
why industry standards exist. And if
Work
it'll plug, yep. And if it plugs into
on
everything,
all of
then it's just less stuff. You don't have to carry around a different set of test leads for every freaking piece of equipment. It's all universal. It all works. And that's why I wanted to point that
Yep.
out. So
Yep.
what else would you include in your field kit? So we've already talked banana clips. We've talked the depth, height, adjustable test leads as well. What else would be valid, or what would you want to bring in the field with you to make sure you have everything you need,
I
multimeter wise?
typically always run with 1 meter, but I usually keep like 2 or 3 in my truck. Because one breaks, you have a backup. Test leads, you only need really one set of test leads because you're only gonna, if one breaks, you're using the other one's test leads. You really just need a backup meter at that point. Me personally, when it comes to, I like to keep one open jaw like this, and then 1 meter like this. And so this clear one that I have right here, this one, yeah, it does. I had to read the fine print on the front of it
Right.
right here, right? But 10 amp input. That's look. I mean, I'm telling you that. How often do you need that thing? Seldom, but
Right.
when you need it, you got it, right?
Right.
So, I can measure up to 10 amps on these inputs. You can measure amps on these open jaw, no
Mm-hmm.
problem. All these wires fit in the jaw. There's no issue with that. But the only problem that I have is not as accurate as passing straight through a meter.
Right. Makes sense.
So I typically just carry like these with me, or it used to be like this and this or whatnot.
Right.
Hell, back in the day, it was like 3 of these.
No, and that's more my speed. Like I said, I haven't done much in the way of testing in probably close to 8 to 10 years here. So FLIR wasn't really a option, and everything we used in the military was definitely the old school flukes that that you could just beat the ever living crud out of, and they would still rock and roll. So
Oh yeah, I mean this
uh,
thing is beat up right here. It's got all kinds of grime on it. It works like a champ.
now you
So,
mentioned the IR camera on the FLIR one, and so it'll get you by if you need it. And how often do you use the IR functionality? Or do
um,
you usually carry your own IR camera?
I have some videos on LinkedIn. Um, you know me. I'm gonna
Mm-hmm.
turn it on real quick. I'm gonna put it on clamp on mode, and that's one thing I was gonna say was you have solid clamps like this, and you can get a lot of meters like this. You can also get attachments like on this FLIR, which is why I like it. In my
Gotcha.
kit that I keep for my FLIR, I have an 18-inch
Uh,
flex clamp,
yeah, I remember
and so this
seeing.
thing just plugs back into itself. But this thing goes from 30. It has scales on it,
Mhm.
30, 300, or 3,000 amps,
Oh, wow,
and it even has. Let me turn this thing on. Turns on flashlight on it. So when
nice.
you're reaching inside the panel, struggling,
You can see
with
it.
no daylight, you can still sit there and get this thing working. And you plug it into the meter and it works great. And why is this important? Because when you go out and you do an IR survey, you're supposed to be like, well, B phase is running hotter, and you're like, well, what's the current on it? If B phase has got twice as much current, of course it's running
It's
hotter.
definitely gonna run
Well,
hotter.
this
Yeah.
little guy right here, you can put it on B phase, and then while you're in IR mode, I have it in current mode. I don't know how well you can see this, but in the top up
Oh,
here, you can
wow.
also see that it shows the current. So now I can see the IR photo
Yeah,
while I strap over it right now, so you can't really see it, right?
I see
But
you
you
now.
can see
Yeah,
the IR photo while you
man, that's
also
sharp.
see the current that you're doing. And then I
Very
can
cool.
snap that picture, send it to my phone, and load it in the report. That's what I like this
Now
thing does.
that's some high tech stuff there. I like that.
Yeah, it is.
Now with that
This
one
thing,
that you had, that's kind of like the amp clamp, the longer one that you use for IR thermography. Didn't you do a video where you can do multiple wraps on that thing and it changes the outputs, or is that a different video?
yeah. So what I was doing, I think, was that battery, the same battery
Yeah,
one. I was trying to measure the ripple
ripple,
current, and the
right?
problem I was having is that it was so low
Mm-hmm.
that I wasn't able to get an accurate reading. And I was on the lowest setting, which is 30 amps, which is really it's a very low
Low amp.
setting,
Yeah.
right? So what I did was I wrapped it around, and so this is one wrap, right?
Right.
So that's 30 amps, right? So now if I go and I wrap it again, now I'm doubling everything because I have 2 wraps. So if I pass 15 amps through here, this is going to show 30
Yep.
amps. If I wrap it 3 times, if I pass 10 amps through this thing,
It'll show 30
it's going to
still.
show 30
Yeah.
amps. And so I was essentially what I was trying to do was I was trying to get more bang for my buck by tripling up my meter.
Now, do you find that the readings were fairly accurate using the wrap method? Did you have anything else to compare it to make sure it was? I know it's all
They
comes down to the
typically,
theory and the formulas of it, and it all makes sense. But how accurate is it for the end
theory
use?
wise, backs up my accuracy results. And theory wise, the problem is the current going through the wire was so low, like
Mm-hmm.
that the magnetic field around it was low. And that's all this thing's looking for. It's looking for a magnetic
Right.
field. And so if I was able to take that same magnetic field and make it apply twice as much, I'm able to see twice as much. And
Right.
therefore my resolution is twice as good.
Gotcha. I was just kind of curious, and I know you kind of, like I said, you touched on it with that last video that you did on it. I thought it was pretty fascinating stuff to kind of show it. And the fact that we have the tech now, because like I said, back when I was doing technician stuff, we didn't have all this cool high tech stuff. So I really like it in the way it functions and everything else. So
Yeah.
definitely some cool stuff. Well, what else you got for us, man, on this multimeter front? We're running 45 minutes here, and I know we're educating the folks, but what else is super salient in the world of ammeters, voltmeters, multimeters, and kind of what we need to consider?
I got one last controversial statement for you.
I love controversy.
So it's not controversial to everyone who knows what they're doing, right? But for engineers, right? But we don't measure resistance. How about that, right? There's no one out there that measures resistance. You don't. You don't measure resistance. You apply a voltage and you measure the current, and your meter internally does the math,
Right.
and it spits out a number and tells you that's what the resistance is.
Gotcha.
Okay.
Gotcha.
Because you can't measure resistance. You only apply a voltage and measure a current, right? You apply a voltage, you measure the voltage, you measure the current coming through the circuit, you do the math on that. And I'm going to prove it to you.
I'm interested. I'm trying to see where Mr. Ohm would fall on this whole thing with his laws here. So
this meter, and I got it plugged in right now, right?
yeah,
I got this meter and I set it the resistance, okay?
mm-hmm.
So just to prove I'm not doing any shenanigans here, this meter, and I'm just going to pass it over the back of my head so you know it's not wrong. I'm going to put it on voltage again. Is literally input into the other meter, okay? So this other meter says nothing, DC, okay? So I want to measure resistance. I'm just going to set it down, nothing crazy. I want to measure resistance. I'm going to switch that to resistance, right? Okay. This meter is going to put out a voltage, and it's going to measure its current coming back through these leads. How do I know that? Because if you go back to this other meter now, it's putting out 2.7 volts.
Gotcha. I see what you're saying.
There's proof in the pudding, right?
Yeah, yeah, it is. So it's actually literally putting out the voltage.
Do this. There we go. Switch it off. Boom, it goes away. Right? This meter is literally putting out voltage. And
that's how the meters function, correct? I mean, they have to have the baseline voltages and currents in order to formulate the resistance. And if you don't have an injection going on of some sort, you're never going to get anything. And that's kind of how the microprocessors work and with the theory and writ large.
If I go to what is beep mode, that's continuity. It's the same thing.
Yep.
So it's crazy because a lot of people are like, well, I'm not measuring any resistance. What about the battery in your meter? Right. You can't put out voltage if you don't have a battery.
Right.
So
I was going to say, if you don't have a battery in it, you're not going to get those readings for dang sure.
So that's why these old analogs, that's the only reason these things had a battery, right?
Yep.
It's the only reason they had a battery.
So they can generate the voltage required.
Voltage to measure a current.
Makes sense.
And then it would just use the exact same scales. You just drop down to the other one, and that's what you would see.
Well, and I see you have an old analog with you. Do you ever find use cases now? And I know, of course, on switchgear and some of the various older panels that we used, we had these things are wired in, and that's just how they're built into the various pieces of equipment that we utilize for on-site monitoring, SANs, meters, or handhelds. But do you find particular use cases for one over the other, or why you would need to use an analog vice a digital, or is that even a thing?
So I'm setting up something right now that's I'm known to go pretty nerdy on stuff.
I love it.
So I'm going to show you something that's known. a lot of people are gonna be like, I don't need this old junk, right? And I literally just got this for this video, right? I have like 2 old ones out in the garage, but they don't work,
Right.
But I got this just for this video. I haven't even tested it yet, so we're gonna find out today. But there's a very good use case for this, and I'm gonna demonstrate it, right? And a lot of only the older guys and a couple guys that know this will appreciate this, okay? But a lot of the people would be like, no, I don't need anything else. I just want my fluke, right? But the problem with the fluke
Right.
is that it's analog or digital. I'm sorry. And so with the digital
Right.
meter, it has to wait for resolution to stabilize before it gives you a display. It's just how they're designed. Your eyes aren't going to see it fast enough, anyways, if it just spits out
Right.
numbers all the time. So the problem though is when you run into circuits where, what if you're troubleshooting a generator and the voltage regulator is hunting, right? And that's when it starts searching for voltage, right? And it's trying to
Right.
stabilize, but it never really can. But what's actually happening? The voltage is changing,
Right.
right?
Along. It's basically
This,
overcomped either way, and you can't really
yeah.
you can't register it on a digital
So
basically.
I'm gonna demonstrate that I have on my side over here. Here, let me slide this over. I have a power supply, AC power supply plugged into the
Gotcha.
wall over here. I can't move my camera, but
Right. Right.
I'm
Right.
gonna demonstrate it right here. So I'm at 0 volts. I'm gonna go up and you can see it's all right. Cool. We're at
48.
48 volts or
Yep.
whatever, right? But if I move too fast, I'm still moving. You can't see nothing. You
It's
don't know
still
what's
trying to.
going
Yep.
on.
It's
And a
going all
lot of
over the
times,
place.
just if you move too quickly, it's just OL, right? So, all right, well that meter is useless if it's moving too quick, right? Well, what about the analog one? And let's pray to God that this thing works right. Oh, I gotta use its leads. Shoot, little leads. Hold on 1 second. You gotta use its leads. They won't plug in. They're tiny little
So
jacks.
much for our theory on universal leads, right? Those 4 millimeter bananas.
These are like 1.5 millimeter
Yeah.
leads. These are old style. They're meant to be a
Right.
tiny
Right.
little
Right.
kit where it just plugs right in. Yeah, you can't plug anything else into this one. But
That's
the
that, that that's
older
that that's
systems
that
and whatnot, you
Radio
can.
Shack voltmeter, right? The one that you can go pick up and knock out for pennies on the dollar, basically.
It's practically what it is. So let me. So this thing's scale is set to 250 volts.
Gotcha.
All right. And so if your generator is hunting, oh my gosh, I can
Yep.
see
You
it's
can
doing
see
something
it
now,
hunting. Yep.
right?
You're so
So
basically the analog will get rid of the time delay in order to actually give you you can literally you get a visualization to kind of show it, and that also makes sense, like especially on the generator stuff, because we used to have the analog voltmeters in like I can't remember what the name of the panels were, but when we're doing power generation for shipboard use, and you could
yeah,
literally watch the fluctuations and stuff, especially when you're trying to kind of fine tune the system. So
yeah, and what it's called is it's called needle deflection.
gotcha,
So you're able to see the actual deflection of the needle and whether or not the circuit's pulsing on, off. You're able to see that. Like
mm,
there are certain circuits out there whether they're PWM based or whatever it might be. PWM might be a little too fast for you to monitor, right? But there's other circuits, and I can like a turbo sleuth is a type of test equipment where literally it turns on and it goes 1 second at 1 amp, 1 second at
gotcha,
3 amps, 1 second at 5 amps.
right.
And so if you're trying to use a digital meter,
It'll
it's
never
really
catch up.
hard to see that.
Yeah.
But it has installed on the front panel an analog meter. It goes,
And that's what I'm used to seeing with some of that stuff. So you can kind of
yeah,
you can pick up the minutia of what's kind of going on and make sure you and like you said
yeah.
deflections.
And what a lot of people don't know is on these analog meters. I'm gonna plug it back in
Digitals,
over
yep.
here. Um, there kind of is that feature built into these, and if you read the manuals you can start figuring this out. But I mean, come on now, in this day and age, who reads the manuals? So I know, right? I read the manuals, but if you
Still
look
do.
right here, it's got this auto range function,
Yeah.
right? I don't know if you can see that, but it's got this auto range
Yeah.
function,
Barely, but
right?
yeah.
And so you can actually turn your range off. Now you're in a manual range. And so now you actually have to select your range. But what's cool about this is that let me turn my range and go up. So now we're at 6 volts, 1,000 volts, manual range. And so now I could go up like this. But what's
There's still a
supposed to
delay.
happen, and I'm
There's
not
a
seeing it
slight
on
delay,
this
but
one.
it's tracking. It's not throwing the overload scenario.
Yeah, well, there we go. If you look, so if you look at the bottom bars at the bottom of it, see those?
I do.
Uh, there's your needle deflection.
Okay, that makes sense. So they do try to compensate for it on the digital
They do,
meters. Is it? But
but it's not
even
the
then, it would
same,
still be. Yeah, I was going to say it still probably doesn't resonate as being close to the same. I'm with you. And I
Whoever
mean,
uses
perhaps it's because
manual
we're old
range,
as dirt, Tom. But I would rather see that bouncing needle doing its thing. So.
yeah, yeah. Different tools for different jobs. That's what it boils down to, But no one, there's a lot of people that don't know about manual range and selecting the ranges on your
Right.
meters and whatnot. I mean, there's a lot of functionality on these things that just never ever gets used.
Now, do you have, and so I know you study on all this stuff on a regular basis. Do you have any reference material for those folks that don't want to go read the manual that can kind of give them a good overview of the minutia that goes on with the multimeters, kind of like a training curriculum thing?
Well, that's a loaded statement you got there because what
This technically
they want to
is,
go
but
somewhere and learn something but not read the manual. um, so I would start with the manual,
of course.
obviously, but I mean, really, basic AC and DC circuits are going to help the most. And I learned something the other day was a lot of people think, yeah, I know Ohm's law. I know what Ohm's law is. I times
Yep.
E
E
equals
use I
P and
times
stuff.
R.
I'm
Yep.
like,
Yep.
that's not basic AC and DC theory. When I'm talking about basic AC and DC theory, I'm talking about how do you calculate a parallel resistance.
Gotcha.
Now, when you start, looking into that's what engineers call basic AC and DC. That's what your colleges call basic AC and DC theory. So when you start researching that, then if you come back to your manual, all of it's going to make sense.
Mm-hmm. No, it makes sense. And for those who aren't familiar with our prior conversations, that was something I think both you and I uh, hinted on or made very clear is you have to have the fundamental grasp of the actual physics and theory in order to actually truly comprehend not only the test equipment, because test equipment has gotten complex enough now to where, or complex enough in design and sophistication to where it's taken away a lot of the need to know some of the basic theory stuff. And so
Yeah.
if you actually truly understand it, then you're going to understand the system within the system and all the other things that kind of come back to, but it all harkens, back to a fundamental great understanding of the physics and the theory of AC and DC is really what it comes
Yeah,
down
I can't agree with that more. I mean, from a relay testing point of view, like RTS InnoServe, it's a software that's designed to make it so that way experienced relay testers can just crank
to.
out any relay, right? Well, what does it end up doing? It ends up making. I'm not trying to pick on anyone. I like
Right.
RTS, but it has its places, and it ends up making people into button pushers.
Yep.
And then you've got a lot of people that can easily operate the software. All they have to know is just what buttons to click in what order, and then all of
Mm-hmm.
a sudden they run into a piece of test equipment that's operating wrong or something. And they're out in the field by themselves, and they've been operating RTS for
Yes.
years, and now they're completely stuck. They can't do anything. They failed or whatever, and so it sets people up for failure if you get to that point. You
Agree.
really do need to
It
know what
allows you to
you're
get
doing before
lazy
you
more
try
than
to do
anything.
anything.
You don't have to keep your brain sharp and fresh with everything because the software really is that good. And I just wrapped up a conversation I think I mentioned with Adam over at ARENT. But like it is that good RTS, and so somebody, if I'm looking at a candidate for a recruiting position, if they just say, "Hey, I'm fantastic with RTS InnoServe," that's great because that just shows me you know how to push the buttons and get through all the tests, and it's become that easy. But what if InnoServe is not working? Now, do you still understand the fundamentals in order to kind of figure out what is actually going
Yeah,
on down the line?
yeah. If you can, if you here, I'll go one step further. Right? If you can say, I'm a fine candidate with InnoServe, but if I give you an electromechanical, I say test it with this. If you can do that, you're good. Okay.
Right. You better lean. You're going to be leaning back to now. We're just in.
I'm going to give you a current source. You just
Right.
go
We'll
out there
give
and
you a current
manually
source,
test
and
it.
now
If you
you have
can
to
do
do the
that,
math to figure out what's going on to get your actual load. So if it's via
yep,
injection testing, whatever it may be, and that's where you really need to have your fundamentals freaking locked on.
that's right.
Awesome, dude. Well, what else you have, man? We're getting close here. We're right at an hour. What other salient points should we leave for our audience from an educational standpoint here?
I don't really have anything else much for the most part. I mean, I got a couple other cool doodads over here that we could play with if we really wanted to, but for the most part, I'd say if you're using your test equipment, know how to use it, understand it, read the functionality, make sure that you have a good kit built out, make sure that you're inspecting your test leads. These things only last for so long. A good little trick for testing test leads, if you're not sure, you could take these leads, take everything all the way up to here, and then you could dip all of the rest of this in a glass of salt water, right? And
Yep.
then measure resistance from A to from red to black. And it should be infinite. It should say OL, open line.
Oh, okay. I see what you're saying.
And
Yep, yep,
so
yep, yep. Got you.
if it doesn't say that, then the salt water just shorted your two leads. It found
Gotcha.
it found the break for you before you're out in the field. Another cool little thing, if you're out there testing panels, a lot of people leave these in their trucks in the winter. They come into a nice little, climate controlled building, and then they pull out their meter, they plug it in and everything. There have been case studies shown that people when that happens, moisture can build up inside these meters and get
Condensate.
trapped.
Yep.
And so then they bring it in and they go up to a 480-volt panel, and the
Hmm.
meter blows out in front of them.
Right.
It had nothing else to do with the leads or
It was
anything. It's
sheerly
just a
the
little the
condensation
meter.
based on the delta
Yeah.
in the temperature.
So, let your stuff stabilize. Make sure you take care of it. All this stuff matters. At the end of the day, it's your life. It's your career, and how well you take care of those things will be evident in your work.
Absolutely, man. Well, I think that that's a great note to wrap up on the precautions and literally just taking care of your freaking equipment. If you don't, you're not going to get all the accuracy that you should out of things, and it just won't
Yep.
last you as long. Then you have replacement cost and everything else. But my friend, that was a fantastic walkthrough. Hopefully, it was elementary enough to where folks that are outside of electrical can kind of understand it, because we got a little bit of a mixed audience, but truly great stuff. And of course, there's tons and tons of test equipment out there. So perhaps the next one we can do on the various aspects of relays. I don't know, or whatever it may be, but we'll definitely get back together. And for everybody else, just if you like this kind of content, let us know. Like I said, Tom's always willing to come to the table and share his knowledge. So thank you very much for that, my friend. I greatly appreciate it. And I think it benefits especially the younger folks, and heck, even some of the more seasoned guys, because like I said, I've got experience with this stuff, and even I'm getting to pick up some new minutia of things that I just simply didn't think through. And you nerd out on this stuff, and it's apparent, and I think it's great. And it truly shows the passion you have for the industry, man, and of course sharing the knowledge as well. And then
Yeah.
for everybody that may not have seen our other videos covering NITA and covering NISET, where can folks find you online?
I'm on LinkedIn for sure, Thomas Wire. You can look me up there. I work with Risa Power now. I mean, if hit me up on LinkedIn if you want to chat or something like that. I've had people reach out before, whether it's sales or just prime power guys wanted to say hi or something like that. I don't mind at all. If you're a veteran and you need some help, either Micah or myself, either of us can help out with that. But if you just want to nerd out on something, I mean, I like to nerd out. So
That's why we have these conversations, man. I know we're not unique in that aspect, but I think it's great. And then just to be able to share it. And that's a really cool thing about the social media platforms, and be able to actually put this stuff out there for the general public to check it out if they so desire. So,
yeah, maybe
with,
our audience can figure out what the next topic could be. Maybe it can be
there
something
you go.
about
We'll put it
negatives
up
or
for a
something
vote or
like that.
something like that, and kind of figure out where we go next. Because, like I said, there's tons of information out there. I don't know if we could get like a full size transformer into your room to kind of show and tell with. You know what I mean? It's kind of small in there for some of that. You might have to take out a wall, but we could do that.
Do some new plumbing on some wiring.
But no, man. Well, I'll let you get back to your Sunday afternoon here. And again, thank you so much for hopping on. And we'll catch up on the backside and figure out what we want to put out there next for folks. And like I said, we'll put it up for a vote, maybe perhaps on the comments on this one as we go to what they want to see next as far as general content. But as always, man, thank you so much for your time. And congratulations on your new role over there at Riza as well. I think it's a perfect fit, and you're doing what you were meant to do, and it's spreading the gospel of electrical education. So,
So I appreciate it.
all right, my friend. Well, folks, until next time, Mike out.